Section 2.8, Distance and Midpoint Formulas and Circles. First, let's look at the distance formula. The distance d between the points x sub 1, y sub 1, those are little subscripts 1, and x sub 2, y sub 2, little subscripts 2, in the rectangular coordinate system is. This is our distance formula. You need to write this down and memorize it. It's the square root, open parentheses, x sub 2 minus x sub 1, and that difference squared, plus y sub 2 minus y sub 1 with that difference squared. So let's begin and look at this example and find the distance between these two points. -1, 4, +3, -2. This is like point 1. Now we know in an ordered pair the first number's x, so x is -1, the second number's y, and it's +4. But since this is point 1, I'm going to label x with x sub 1 to represent -1 and y sub 1 to represent +4. Now this second point, I'm going to label this point 2. Well, again, it's an ordered pair. The first one's x, the second one's y. But since this is point 2, I'm going to give these x's and y's little subscripts of 2. X sub 2 is 3, y sub 2 is -2. We use subscripts to distinguish between that both of these are x's, but x sub 1 comes from point 1, x sub 2 comes from point 2. So let's use our formula. The distance between these two points is the square root of x sub 2, open parentheses, x sub 2 is 3. The minus sign comes from the formula. 3 minus x sub 1 is -1, close parentheses, squared, plus, open parentheses, y sub 2 is -2. Minus comes from the formula. Minus y sub 1 is 4, close parentheses, squared. Now, minus a negative, subtracting a negative, think about it. Subtraction means add the opposite. This becomes 3 plus +1 squared, plus -2 minus 4 squared. All still under the square root symbol. Now, 3 plus 1 gives you 4. We will square 4 plus -2 minus 4. That's -6 squared. Now, continuing next, we would raise each number inside the parentheses to the power. 4 squared is 16, plus -6 squared. -6 times -6 is +36. 4 squared, 4 times 4 was 16. -6 times -6 was +36. Okay? Continuing on, 36 plus 16. 36 plus 16 gives us the square root of 52. Now, that's the actual value, but we're going to leave our answer in simplified radical form. And also, you may be asked to round it to maybe the hundredths place. So we're going to talk about that too. All right, if dealing with reducing this radical, I want to talk about the square root of 52 and simplifying this radical. We will use our perfect squares to try to simplify this radical. So let's talk about our perfect squares. Recall that the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. And we continue on with the square root of 64 is 8. And this list goes on and on and on. But in trying to take the square root of 52, we see that square root of 52 has been skipped. It is not a perfect square. So we begin thinking about the perfect squares, 4, 9, 16, 25. Will any of these divide into 52, and what is the biggest one? Well, I know 4 will divide into 52. If I use my calculator, 52 divided by 4 gives me 13. 9 will not divide into 52, 16 won't, and none of the rest of these will. So the first thing I need to do is I need to use the fact that 4 times 13 gives me 52. I looked at my perfect square list. I found the largest perfect square that would divide into 52, and it is 4. And 4 times 13 is 52. Now, the square root of 4 is 2. So when I take the square root of 4, it comes out of the radical as 2, leaving 13 underneath. So this is your simplified radical form. Now, if you have been asked to find your answer rounded to the nearest hundredths, let's say your answer is supposed to be rounded to the nearest hundredths. Well, go back and let's put this in your calculator. Type in the square root of 52. If you type in the square root of 52, you get something like 7.2111 and a few more numbers, okay? But the hundredths place is this 1. The 2 is in the tenths, this is the hundredths. So does this 1 stay a 1 or does it need to become a 2? Well, you look to the digit to the right. If it's 5 or greater, the 1 becomes a 2. If it's 4 or less, the 1 stays a 1. So in my case, I have a 1, so that is less than 5. So therefore, if I was to round this answer to the nearest hundredths, my answer would be 7.21. Okay? All right. Well, let's look at another example involving distance. I want us to use the distance formula again. So let's look at this problem. So, again, I want you to memorize that distance formula. D is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Remember how we labeled these. This was point 1, so this is x sub 1, y sub 1. This is point 2, so this is x sub 2, y sub 2. So let's run it through our formula. D is equal to the square root. X sub 2 is 1 minus x sub 1 is negative 4, and that is in parentheses squared. Now this minus sign comes from the formula. So x sub 2 is 1 minus x sub 1 is negative 4 plus y sub 2 is negative 3 minus negative 3 minus 9, close parentheses, squared. Okay? So again, we have that minus that negative. So adding the opposite becomes 1 plus positive 4 squared plus negative 3 minus 9 squared. So continuing on, 1 plus 4 is 5. I'll have to take 5 and square it. Negative 3 and negative 9, that gives me negative 12 squared. Okay, so working on down, 5 squared is 25. 12 squared, 12 times 12, negative 12 times negative 12 is going to give me 144. Well, if you add those together, you get 169. Okay? Now, the first thing you want to do always is just to see if you can take the square root of 169. So punch in your calculator and take the square root of 169. When you do, your answer is 13. That is your final answer. That is an answer as far as if they tell you to round to the hundredths, that's your answer. Simplified radical form, we took the square root, so that is as far simplified as I can go. So that is my final answer on that problem. The next thing I want us to look at is the midpoint formula. Consider a line segment whose endpoints are x sub 1, y sub 1, and x sub 2, y sub 2. This would be like a segment. A segment is part of a line. This is x sub 1, y sub 1, and this point would be x sub 2, y sub 2. Now, we're trying to find the midpoint. The midpoint is a point in the middle of the segment. I'm going to note the midpoint being capital M. A midpoint is a point on the segment in the middle. It splits the segment into two equal parts. All right, so the coordinate of the segment's midpoints are, this is how we find the midpoint. This would be your midpoint formula. It is an ordered pair, so I need parentheses and a comma in between. The way you find the x-coordinate, you add the two x's together, x sub 1 plus x sub 2 divided by 2. You add the y's together, y sub 1 plus y sub 2 divided by 2. To find the midpoint, take the average of the two x-coordinates and the average of the two y-coordinates. So here you are adding two x's, dividing it by 2, that's the average. You're adding two y's and dividing it by 2. So let's use this formula to find the midpoint of the line segments whose endpoints are 1, negative 6, and negative 4, negative 8, negative 4. So let's label these points. This is like point 1, x sub 1, y sub 1. This is like point 2, x sub 2, y sub 2. So using that midpoint formula at the top of my screen, x sub 1 is 1 plus x sub 2 is negative 8 divided by 2, comma. Add your y's together. The formula says take y sub 1, negative 6, plus y sub 2's negative 4, and divide by 2. You will add what's in the numerator first. So to do that, let's add what's in the numerator. 1 plus negative 8 is negative 7 divided by 2. Negative 6 plus negative 4 is negative 10 divided by 2. Now, negative 7 halves we will leave. That is in reduced fraction form. But I can reduce negative 10 divided by 2 gives me negative 5. So my final answer for this problem, to find the midpoint of the line segments of those particular endpoints, your answer is negative 7 halves, comma, 5, negative. Both of them are negative. All right, let's look at one last problem in finding the midpoint. Find the midpoint of the line segment with endpoints 1, 2, and 7, negative 3. This is x sub 1, y sub 1. This is x sub 2, y sub 2. Finding midpoint. I'm going to let that be capital M. Going by the formula, add the two x's together. X sub 1 is 1 plus x sub 2 is 7 divided by 2. Add the y's together. Y sub 1 is 2 plus y sub 1 is negative 3 divided by 2. Working inside the numerator first, add the two numbers together. 7 plus 1 is 8 divided by 2. Adding the two numerators here, 2 plus negative 3 is negative 1 divided by 2. Can we reduce either one of these? In order for the online homework to take the correct answer, they will want it in reduced form. 8 divided by 2 is 4. And then negative 1/2 is in reduced form. So your midpoint answer for this problem would be the ordered pair 4, comma, negative 1/2.